All right, so let's take a look at the Unit 10 review sheet. So number 1 gives us an equation that represents the height above the ground for a person riding a Ferris wheel. Okay, so letter A, what is the maximum height a person will reach on the Ferris wheel? Okay, so we know this formula right here, right? Max equals vertical shift plus amp. So the vertical shift is this number right here that's added to the end of the equation. So that's going to be 160. And then plus, if we look right here, our amplitude is 150. All right, so what we have to do is just add these together, and that gives us 310. And the units would be feet, so 310 feet. Okay, part B, how many seconds does it take to go from the bottom of the wheel to the top of the wheel? Okay, so when we're looking for how many seconds, we're really thinking in our head, all right, how long? Now, what represents how long something is within a trig function? Well, what we're looking for is how long is the period. So we know that period is equal to 2 pi divided by the frequency. Okay, so the frequency is this. It's what's in front of the, usually an x, but in this case it's a t, but what's in front of the t in our equation, so pi over 45. So we have 2 pi divided by pi over 45. My pen's not working here. All right, there we go. Now, when you're dividing by a fraction, you could either do keep, change, flip, which is really the same thing. It's just multiplying by the reciprocal. Okay, so again, if you do keep, you're going to keep the numerator. Change means we're going to change this division to multiplication. And flip tells us we're going to flip this upside down. Now, instead of saying keep, change, flip, I know some of you like to say, well, let's just multiply by the reciprocal, because that's really what you're doing when you do keep, change, flip. All right, so if we multiply this out, let me put this over 1. This pi on top cancels with the pi on the bottom. And 2 times 45 would be 90. Now, I just want to explain something. 90 seconds is the amount of time it takes for this Ferris wheel to make one complete rotation. So if it were to go from the bottom all the way around to the bottom again, it would take 90 seconds. Now here we just want to go from the bottom to the top. So if it's going from the bottom to the top, it's only going halfway around. So we're going to take this period and we're going to cut it in half. So if you take 90 seconds and cut it in half, that tells you it's going to take 45 seconds to go halfway around. Okay, it's going to take 45 seconds to go from the bottom to the top. All right, so let's take a look at number 2. Now here they give us a picture and they want to know which one of these equations is represented, in this picture right here. Okay, well, let's just go through. So first thing, we know the number in front of the word sine or cosine is the amplitude. So I'm just going to use our amplitude formula. So we know that amplitude is equal to max minus min divided by 2. All right, so if we look at the graph up there, the maximum y value that our graph reaches is right here, okay? Now, since these are going by 2, right? So this is 2, 4, 6, 8, 10, 12, 14. The maximum right here is at a height of 14. So I'm going to replace max with a 14. And then minus, so the min is right here. If we follow that over, again, since we're jumping by 2s, if this is 2, this will be 4. The minimum is at a height of 4. Then we're just going to divide that by 2. All right, so 14 minus 4 is 10, and then 10 divided by 2 is 5. Oh, I'm putting a 5 there instead of here. Okay, so our amp is 5. So that being said, we can cross off choice 2 and choice 3, right, because these have amplitudes of 9. Now, since you could see there's no horizontal shift built into the equation, because if there was, right, wouldn't there be like a minus or a plus sign in here? Since there's no horizontal shift, that means our curve is starting at the midline, right? See how it's starting? Here's our midline. So it's starting at the midline. So we know that a sine curve starts at the midline, right, and goes up, down, and ends up back at the midline again. Whereas a cosine curve would have started at its maximum. So this has to be a sine curve. So I can actually eliminate choice 1, and choice 4 is the answer. Now, I'm going to go into more detail about this. If you understand it, you can kind of go to the next question, but I'm going to just quickly go over where this frequency comes from and where this vertical shift comes from. But let me start with the vertical shift. So this plus 9 at the end. We know that our formula for vertical shift is maximum minus amplitude. So if you look, sorry, this is a little messy. If you look, we've already said the maximum height is right here at 14. And then minus, we found the amplitude to be 5. So if we do 14 minus 5, we get 9. And that's why we have a 9 as our vertical shift here. Okay, now this in here represents our frequency. We know, where do I have room to do this? I'll just come over here. We know that frequency is equal to 2 pi over the period. Now the period is how long it takes to complete one cycle. So if we look at our graph over here, right? Let me just kind of outline one cycle. Here's sine curve starts at the midline, halfway through its cycle, it's at the midline, and it also ends at the midline. So this right here is one complete sine curve. So where that happens is at 12. This 12 is our period. Okay, it takes 12, I guess, what are we talking about here? Time in hours. So it takes 12 hours to get there. So anyway, I'm going to replace the word period with a 12. And since 2 over 12 simplifies to 1/6, this will simplify to 1 pi over 6, or just pi over 6. And that's how we get this frequency. All right, number 3. All right, so given this equation, they want us to determine these 3 things. Okay, so the maximum, I'm going to use our formula for maximum. The maximum, is equal to the vertical shift plus the amplitude. Okay, so our vertical shift is 140, right? It's the number that's being added or subtracted to the end of the function. And then the amplitude. Now, the amplitude, it's not negative 110, right? Amplitude can't be negative. You can't have a negative height. The negative just tells you that the sine curve is going to go down before it comes up. But the amplitude itself is just this 110. So if we do 140 plus 110, that's going to give us 250. So that's our maximum value. If it had asked for the minimum value, all we would do is change this to a minus sign. Okay, the period. So our formula for period is equal to 2 pi over the frequency. Now the frequency is whatever is in front of the x in our equation, which in this case, instead of an x, we're using a t. So this pi over 6 is our frequency. So we're going to have 2 pi divided by, sorry, this pen is not working well today. So 2 pi divided by pi over 6. All right, so whether you multiply by the reciprocal or do keep, change, flip, we're going to be left with 2 pi times 6 over pi. So then what happens is the pi on top cancels with the pi on bottom, and it leaves us with our period being 12. Okay, horizontal shift. So we know that the horizontal shift can be found in here. And the formula is really, I'm going to say it with a t instead of an x, t minus the horizontal shift. So because there's a minus sign in the formula, we know we take the opposite sign of what's here. So the horizontal shift is, is going to be negative 15. Okay? If you were going negative 15 units in the negative direction, right, wouldn't that mean we're going left 15 units? And when this equation is a plus sign in there, doesn't that mean we're going to the left 15 units? Okay, so our horizontal shift is negative 15. One more thing I just want to point out. I mean, the other thing I guess they could ask for you in this formula would be the vertical shift, which is 140. Or let's just say they ask for the midline. I know they don't ask for this here, but let's say they ask for the midline. The midline has to be written as an equation. Okay, your midline is equal to y. It's y equals your vertical shift. Okay, so since our vertical shift is 140, if they had asked for the midline, it would be y equals 140. And I mean, that's pretty much all they could ask you, given this equation. Okay, number 4, which equation could be represented by the graph below? So, I mean, first thing, if you look at all of these equations, right, none of them contain a horizontal shift. So that being said, because our graph is starting at the maximum, dropping down and ending off a cycle at a maximum, this is our cosine curve. Now, they all say cosine, So that unfortunately isn't going to help us. So let's look at all these individual characteristics. Okay, let's start with the amplitude, right? Here, 1 and 2 is saying the amplitude is 50. Choice 3 and 4 is saying the amplitude is 150. Now, we know our formula for amplitude is max minus min divided by 2. So if you look at the graph, you could see that we have a maximum value at 150. Okay, right here is the maximum at 150. And the minimum value is all the way down here, which is at 50. So I'm going to write 150 minus 50. And then we're going to divide that by 2. So basically, 100 divided by 2 is 50. So our amplitude is 50. So that being said, let's cross off choices 3 and 4. Okay, now, choices 1 and 2, they both have a vertical shift of 100, which, you know, basically, if you did have to find the vertical shift is equal to your max minus the amp. So since our max is 150, and we just found the amp to be 50, we can see why the vertical shift would be 100. But that doesn't really help us cancel off one of these. So what we have to do is we have to find the frequency. Is the frequency pi over 4, or is the frequency 8? Now, some of you may be able to tell, right? If your x-axis is in terms of numbers, we know we're going to have a pi as our frequency in the answer. If your x-axis is in terms of pi, most times those pi's are going to cancel off, right? And you'll be left with just the numerical frequency. So I could tell off the bat it's probably going to be choice 1, but let's just double check. So we know that frequency is equal to 2 pi over the period. Okay, so the period is how long it takes to complete one cycle. Now we could see from here to here is one complete cosine curve. So if you notice, look, it took us 8 units to get there. So the period is 8. Okay, this right here is our period. So I'm going to replace that with period. And since 2 over 8 simplifies to 1/4, we're left with 1 pi over 4. Or just better yet, pi over 4. Okay, and that's what it says right here in choice 1. So choice 1 is our answer. All right, number 5, it looks like they again give us a picture and they want to know which could be the equation. Okay, so let's just do the same thing. Let's first start off, let's find our amplitude. So we know that amp is equal to max minus min divided by 2. I'm not going to write the formula this time because we already did a couple times. So the max is at a height of 5, right? And then minus, the min is down here. Actually, look at -1. So we're going to write minus -1 divided by 2. Now, since minus negative becomes a plus, it's really 5 plus 1, which gives us 6. And 6 divided by 2 simplifies to 3. So if our amplitude is 3, right, it has to be choice 3 or 4. So I'm going to cross off choice 1 and 2. Okay, now let's look in here. The next thing we have is our, down here, frequency. Now, again, I can tell if the x-axis is in terms of pi, the frequency is going to have to be a number. If the x-axis was in terms of numbers, right, like this one, see how the x-axis was in terms of numbers? That's when we have a pi as our frequency. But let's just do it. I always like to, be sure the right answer is there. So the frequency we know is equal to 2 pi divided by the period. So 2 pi divided by, well, let's see, the period is from here to here is one complete cosine curve, right? And here, I'll kind of sketch it out from here to here. It's one complete cosine curve. So it takes us 2 pi over 3 units to get there. So 2 pi over 3 is going to be our period. Okay, so we're going to do basically either keep, change, flip, or that's the same as just multiplying by the reciprocal. So we're going to have 2 pi times 3 over 2 pi. All right, well, if we put this over 1, the 2 pi on top cancels with the 2 pi on the bottom, leaving us with 3. So our frequency is 3, which matches up with choice 4 right here. Okay, to find the vertical shift, we know the vertical shift is equal to the max, which is 5, minus the amp, which is 3, and that's how they get the 2. Okay, and then finally on the bottom of this page, number 6. So the hours of daylight, Y, in Utica in days X from January 1st, 2013 can be modeled by this given equation. Okay, what is the minimum number of hours of daylight to the nearest tenth? All right, so to find the minimum, right, let's just use our formula for minimum. Minimum is equal to our vertical shift minus the amplitude. Okay, so we're just going to do 12.23 minus 3.06. Okay, so when we do that, right, let's see, so 12 minus 3 is 9. And then 0.23 minus 0.06 would be 0.17. Okay, so now they say they want it to the nearest tenth. So to the nearest tenth, that is going to be, I'm actually going to put my answer up here. I'm out of room a little bit. 9.2, and the units would be hours. Okay, so part B, how many hours of daylight, again, to the nearest tenth, does this model predict for February 14th, 2013? Okay, well, it says here that X represents the days from January 1st. So I guess what we first have to do is figure out how many days from January 1st is February 14th. Okay, well, let's think about it. So there's 31 days in January, right? So that means there's 30 days remaining in January. And then in addition, sorry, that's supposed to be a 3. In addition, we need 14 more days, right, to get us to February 14th. So altogether, February 14th is 44 days from January 1st. Okay, so that's representing our X. So we're going to take the 44 and substitute it in for X into our equation. All right, so what we did was we replaced the X with the 44. And now I'm just going to type this whole thing in my calculator. Okay, so the first thing you want to do, you want to go to mode and make sure, see right here where it says radian and degree, make sure that you're in radian mode, okay? And then I'm just going to clear out of that screen. And let's just, on a blank screen, I mean, you could do it in the graphing, you know, in y equals if you want. And then you could go to the table of values. But it's just, in my opinion, it's just easier to just plug it in right here. So I'm typing in 3.06. And then I'm hitting the sign button right here. Okay, see sign. And it opens a parenthesis for you. So now I'm just going to type in 0.017. And you could just hit the times button, or if you want to put the 44 in parentheses, that's up to you. And then minus 1.40, which I'm just going to type in 1.4, and then close those parentheses and hit plus 12.23. And you can see that to the nearest, I think it said 10th we underlined, right? We would get 10.4, right? Because this 7 rounds that 3 up to a 4, so 10.4 hours. Okay, number 7 wants us to graph this function over the domain from 0 to 4 pi. Okay, I'm going to first just make a list of certain things that we may need, you know, to help us out. Okay, so the first thing I'm going to write down, I'm just going to kind of list everything off to the side here. Our amplitude is the number in front of the word sign, so that's going to be 4. The frequency is the number in front of the x, which is 1/2. Okay, so that means we're fitting a half a cycle. Frequency means how many, right? So we're fitting a half a cycle between 0 and 2 pi. So we're going to fit a full cycle then between 0 and 4 pi. Okay, the period we know is equal to 2 pi over the frequency. So 2 pi divided by 1/2. So if you did keep change flip, right, or if you did multiply by the reciprocal, you'd have 2 pi times 2 over 1, which gives you 4 pi. So the period is 4 pi. That means it takes 4 pi units to graph one complete cycle, which works out perfect because they want us to graph this between 0 and 4 pi. Okay, this number right here, the -3, is our vertical shift, which also tells us our midline would be, here, I'll just put that in parentheses, the midline would be at y equals -3. Okay, our minimum is equal to the vertical shift minus the amplitude. So -3 minus 4, which is -7. And then the maximum is our vertical shift plus the amplitude. So that gives us +1. Okay, so this just helps me with how to graph it. So let's start with right here. The minimum is at -7, the maximum is at 1. So when we number our y-axis here, the maximum, we only have to number up to 1. The minimum is going to be down at -7. Now, I'm actually not going to put all the numbers, so I'm going to just go down to -1, 2, 3, 4, 5, 6, 7, and I'm just going to put a number right here at -7. The other place I'm going to put a number is at our midline right here, okay? At y equals -3, we're going to have to draw a line. So I'm going to put -3 on this axis as well. And everything should be spaced evenly, right? From the midline, we go up 1, 2, 3, 4 boxes to get to the maximum because our amplitude's 4. And from the midline, we would go down 1, 2, 3, 4 boxes to get to the minimum. Okay, so now when we number the x-axis, right, we need to number up to 4 pi. Now, you don't have to put every component on the axis. Like if you want, ready? However you want to space this out. Normally we jump 2 boxes and we write pi over 2. 2 more boxes and write pi. I'm going to skip labeling every other number because I think it's going to make our life a little easier, right? If we skip 2 boxes, that would be 3 pi over 2, and 2 more boxes would be 2 pi. So basically what I'm doing is I'm jumping 4 boxes over to label pi, another 4 boxes to label 2 pi. So if I go another 4 boxes right here, I'm going to be at 3 pi. Now I'm going to put that little in-between marker, and then I'll label this one 3 pi. Okay, I'm going to put my little in-between marker 2 boxes later, and then 2 boxes later, I've reached 4 pi. Okay, and that's good. You don't have to label all these in-between spots, unless you want to. Okay, so now we have a sine curve. We know the sine curve starts at the midline. Now what I like to do is at the midline, I like to draw a dotted line because that helps me with where I'm going to put all my in-between points on the graph. So we know that sine starts at the midline, so it's going to start, our curve is going to start right here. Now, since the period is 4 pi, that means once we reach 4 pi, we will have fit one complete sine curve. Now remember, the sine curve begins on the midline, ends on the midline, and halfway between those 2 points is on the midline. So what I'm going to do is, since the period is 4 pi, since our curve is ending at 4 pi, at 4 pi we know we're going to be right here at the midline again. And then halfway between the start and the end of your cycle, so halfway between 0 and 4 pi is 2 pi. We're going to be on that midline again. Okay, now if it's a positive sine curve, which this is, we know that between these first 2 points that are on the midline, we're going to be up at a maximum. So if I go halfway between 0 and 2 pi, I'd be at pi. And I need to go up to my maximum, which we said is at 1, right? And we're going to put a point right there. Oop, wrong spot. There we go. Okay, now halfway between the second and third points on the midline, we're going to be down to minimum. So halfway between 2 pi and 4 pi would bring me right here in the middle to 3 pi. I'm going to go down to my minimum of -7 and put a point there. Okay, and then basically let's connect it to make a nice, smooth, and non-pointy sine curve. All right, now I'm going to label it T of x. You don't have to write the whole equation. I mean, if you want to, you can, but you could just give it its label. Okay, so now number 8. Number 8 has 2 parts. The first thing they want us to do is they want us to write an equation for a cosine function with an amplitude of 3, a midline of y equals 2, and a period of pi. Okay, now the first thing I want to point out, because they use this word function, okay, please don't write y equals. We want to write it in function notation. So I'm going to write f of x equals. Now they tell us that we have an amplitude of 3. Okay, so I'm going to put 3 in front of cosine because it says it's a cosine function. Now, in front of the x is where we put the frequency. Now, they don't come out and tell us the frequency, but what they do tell us is that the period is pi. So since we know that frequency, do this off to the side, is equal to 2 pi over the period, well, 2 pi divided by, since the period is pi, I'm going to put that over pi. This would simplify, right? The pi on top cancels with the pi on bottom. This would simplify to 2. So we know the frequency is 2. So I'm going to put a 2 in front of the x, close that up. They don't say anything about a horizontal shift, but they do tell us that the midline is y equals 2. Okay, remember the midline is y equals the vertical shift. So they're telling us that we have a vertical shift of positive 2. Okay, so this is the answer to the first part. This is an equation for the cosine function. Okay, so now the second part wants us to graph this function on this interval from negative pi to positive pi. All right, so I'm going to first just label my x-axis. I'm going to jump 2 boxes up from 0 and label that pi over 2. 2 more boxes and label that pi. And then I'm going to just do the same thing in the negative direction. Now, before I label my y-axis and before I decide, how I want to graph this, I'm just going to pick out some important features. Okay, let me give myself a little more room over here. So I just like to list everything out. So the amplitude we know is equal to 3. The frequency we found to be 2. We were told that the period is equal to pi, and we know the vertical shift is equal to 2. Okay, I also want to just find the min and the max. Now we know that the min is equal to our vertical shift minus the amp. So 2 minus 3, which equals negative 1. So that's the minimum that we're going to need on the y-axis. Okay, now the maximum is equal to the vertical shift plus the amp. So 2 plus 3, which gives us 5. So that's going to be the maximum y value that our graph includes. So along the y-axis, right, we need to number all the way up to 5. So 1, 2, 3, 4, 5. Okay, so we can't jump boxes. I'm just going to put a 5 here. And then we have to go down to negative 1, which would be right here. You could number everything if you want. That's up to you. Now, we also know the vertical shift, or our midline, is at y equals 2. Okay, so that's going to be, basically, our graph is shifted up 2 units. That's going to be the middle height of our graph. So I'm going to put the 2 on our y-axis as well. Okay, you could number everything. You could number some things. It's up to you. Honestly, along the y-axis, if you're jumping by ones, you don't even have to number them at all. All right, so what I like to do is I like to put a dotted line where the midline is. So at y equals 2, I'm just going to put a dotted line. Okay, that's where all my middle points are going to go. All right, now let's think about this graph. We have a cosine curve, right? And we know a cosine curve, I'm just going to change colors here. A cosine curve starts high, drops down low, and ends off high. Okay, so it starts at the maximum, ends at the maximum, and midway between, it's at our minimum. And then we know our midline is going to be right here, which is where we find our other 2 points. Okay, so let's just take a look at some things. If the period is equal to pi, that means it takes us pi units to complete one complete cycle. So I'm going to start on the y-axis at my maximum. Okay, so on the y-axis, I'm going to be up here at my maximum, which is 5. And we know that since the period is pi, once I have gone pi units, I'm going to complete one cycle. And we know the cycle ends at a maximum as well. So I'm going to end my cycle right here at pi 5. Okay, so at pi, I'm going to be up at 5. Now, halfway between your two maximums, you're going to be down at a minimum. So if I meet halfway between these 2 points, I'm going to be at pi over 2 along the x-axis, and I'm going to go all the way down right here to my minimum, which is at -1. Right now, halfway between any maximum and any minimum, you're going to be on that midline. So here's a maximum, here's a minimum, right? To get from here to here, I went 2 boxes over. So half of that would just be 1 box over. So at 1 box over, I'm going to be on my midline right here. Okay, and same thing in between these 2 points. Between this maximum and minimum, I'm going to be at my midline. Okay, so 1 box over from each of these, I'm going to be at the midline. Okay, so this is one cosine curve, okay, between 0 and pi. Now we have to do the same thing in the, from negative pi to 0. So, basically this is going to be the end of the cycle. So the beginning of the cycle would be right here at negative pi. Halfway between these 2 maximums, okay, 2 boxes over from each, we're going to be down at a minimum, which is -1. And then halfway between any maximum and minimum, you're going to be on that midline. So since there's 2 boxes horizontally between the maximum and the minimum, right, there's 2 boxes between these. If you go 1 box over in either direction, you're going to meet in the middle at the midline. Okay, and same thing in between these 2. So really, when you connect these, we are fitting 2 complete cosine curves because we're graphing from negative pi all the way to pi. Okay, so you can label it f of x, you can write the whole equation, that's up to you, but just make sure that you label it. Okay, number 9, this one's kind of a lengthy problem, there's a lot going on, but so let's just see. The temperature in a house is controlled by an electric thermostat. The temperatures throughout the day vary sinusoidally, which just means it's just going to basically go up and down like a sine curve or a cosine curve, okay? It's going to be cyclic. It's going to repeat the same cycle over and over again. So a maximum temperature occurs at 22 degrees Celsius, and that's at 4 a.m., and a minimum temperature of 17 degrees Celsius occurs at 8 a.m. All right, so part A wants us to sketch a graph of the temperature in the house over a 12-hour interval as a function of time t. Assume that t equals 0 corresponds with 12 a.m. Okay, so let's first label our axes. So we know that the x-axis is our time axis, right? And in this case, time is going to be in hours since 12 a.m., right? We're assuming that t equals 0 corresponds with 12 a.m. So this is going to be in hours since 12 a.m. Okay, and they want us to graph it over a 12-hour interval. So basically, you have to number up to 12 on the x-axis. I'm going to just label every other number. So I'm going to jump 2 boxes, make that 2 hours past 12 a.m., 4 hours past 12 a.m., and so on. So I'm going to number that all the way up to 12. Okay, now, the y-axis, right, is going to represent our temperatures, and it's going to be in degrees Celsius. So let me label that temp in degrees Celsius. Now, we know that the maximum temperature is 22, and the minimum is 17. So you're going to want to fit that, basically at least up to 22 along the y-axis. Looks like there's 12 boxes here, so you could just jump by 2s if you want. You can make this 2, 4, 6, 8, and so on. I'm only going to number every other number. So if this is 2, right, this one right here would be 4. So then this would be 6, and then this next one would be 8. So basically, you're just jumping every 2 boxes, and you're numbering by 4s, right? 4, 8, 12, 16, 20, and then 24. Okay, so this is our temperatures in degrees Celsius. Now let's just read what they say. They say a maximum temperature of 22 degrees occurs at 4 a.m. So at 4 a.m., we're going to be at a maximum temperature of 22 degrees. So let's plot that point. Okay, at 4, we're going to be at 22. Now, it also says a minimum temperature of 17 degrees occurs at 8 a.m. So at 8 a.m., we're going to go up to 17. So if this is 16 and this is 18, 17 is going to be midway between them. All right, so there we go. Now, since the temperatures vary, sinusoidally, which means they follow the same cycle over and over again. Let's think about this. If it took 4 hours, right, to go from a maximum to a minimum, won't it take another 4 hours to go from a minimum back up to a maximum? So 4 more hours past 8 a.m., right? That'll bring us to noon, 12 p.m. We're going to be up at a maximum temperature of 22 degrees again. So at 12, we're going to be up at 22. Okay, now, same thing if I were to work my way backwards, right? If it took me 4 hours to go from a max to a min, right, and 4 hours to go from a min to a max, basically if I'm working backwards, if I backtrack 4 hours, I'm going to be down at a minimum of 17 degrees. So at time t equals 0, we are going to be at 17 degrees. So it's going to follow the same pattern over and over again. Now remember, whether you're doing sine or cosine, right? Any curve could be written as a sine function or a cosine function. But halfway between any minimum and any maximum, you're going to be at the midline. Okay, and halfway between any maximum and any minimum, you're going to be at the midline. So let's just figure out where exactly that occurs. All right, so, I'm going to actually write a whole bunch of information over the side here. All right, let's start with the amp. We know that our amp, right, the formula for that is max minus min divided by 2. So the max is 22. The min is 17. And we're going to divide that by 2. So again, amp is equal to max minus min divided by 2. So 5 divided by 2 would be 2.5. Or 5 halves, however you want to write that. I'm going to write, what can I fit? 2.5. I'll write it as a decimal. All right, might as well just do the frequency, all that kind of stuff too. So we know the frequency is equal to 2 pi divided by the period. Now the period is the horizontal length of one complete cycle. So, you could look at this as, if you go from a min to a min, isn't that just an upside down cosine curve, right? And it takes us 8 hours to get there. Or if you want to look from one max to the next max, right? Isn't this a complete cosine curve as well? Which to go from hour 4 to hour 12, again, that would be 8 hours. So the period itself is 8. Okay, you could look at this as a sine curve as well, but because we don't have any points in our midline yet, and that's where a sine curve starts, I'm just looking at it as a cosine curve. Whether it's a sine or a cosine curve, the period is the period. So either way, it takes 8 hours to complete one cycle. All right, so our frequency is going to be pi over 4. Okay, so we know the amplitude is 2.5, the frequency is pi over 4, the period is 8. Now let's figure out, let's do our vertical shift, right? Because isn't that where our midline is going to be? That's what we're kind of looking for to complete our graph here. So the vertical shift, we know the formula for that is max minus amp. So the max is 22. And we just found the amp to be 2.5. So 22 minus 2.5 equals 19.5. That's where our vertical shift occurs. Okay, so let's look at our graph here. If this is 18 and this is 20, midway between would be 19. So 19.5 would be 3/4 of the way up. So 3/4 of the way up, I'm going to do my best to do that. Sometimes it's hard on this. I'm going to put a dotted line, okay? This right here is at 19.5. Okay, so there we go. Now, again, we know that halfway between any min and any max, we're going to be on the midline. So let's figure out exactly where that's going to be. Well, since it takes 4 hours, right? 1, 2, 3, 4, to get from a min to a max, half of 4 would be 2. So after 2 hours, we're going to be on that midline. Okay, then 2 hours after our maximum, we're going to be on our midline again. Okay, and then same thing here. If you go 2 hours past this minimum, we're going to be up at the midline again. Okay, and this is our cycle from time t equals 0 to time t equals 12. And you could see, right, we have an upside down cosine curve here. We have a regular positive cosine curve here. You could see we have a sine curve here, right? Depending on where you look at the beginning of the cycle, right, where the horizontal shift is. Now, in part B, they want us to write a cosine equation for T, the temperature in the house, as a function of the time T since 12 a.m. So when they want you to write it as a function, they're not looking for you to write y equals, right? They're looking for you to write it in function notation. So they're coming out and telling us to write it as T of T, the temperature in terms of time. Okay, so I'm going to write T of T, temperature in terms of time. Okay, it's going to be equal to. Now, it's up to you. You can either have a negative cosine curve, right, like this, or you can write the function in terms of a positive cosine curve. I'm going to do it both ways. By the way, there's infinitely many equations you could write here, but I'm just going to pick the two, I think, most common ones. Okay, so first one. Let's say we looked at, a lot of times it's easier to look at a curve if it starts on the y-axis, if a cycle starts on the y-axis, because then you don't have to worry about a horizontal shift. Okay, so we have, if we look at this is basically a negative cosine curve, right? If we're starting on the y-axis here, if we're looking at the cycle starting here, this is an upside down cosine curve, so a negative cosine curve. So basically, we're going to put a negative in front of the amplitude, which we already found to be over here, 2.5. And then we could put the word cosine. Okay, then in parentheses, we put the frequency, which we found to be pi over 4, in front of, normally an x, but in this case, we're using a t, right, lowercase t. Now, since our cycle started, this negative cosine cycle started at the y-axis, it means we don't have a horizontal shift, okay? We shifted 0 units. So I'm going to just close up those parentheses. And then we're going to have plus our vertical shift, which we found to be 19.5. So this is one equation that you could have written. Okay, now I'm going to put or, because that's a great answer, okay? You can use that answer. Now, another one you could have used is, again, we're going to start off with T of T equals. If you didn't want to write a negative cosine curve, let's look at where the beginning of a positive cosine curve starts. So if you look up here, doesn't the positive cosine curve start at its maximum, drop all the way down to the minimum, and end off at the maximum again? So this right here would be the start of a positive cosine curve. So let's write positive 2.5. Okay, and then cosine of, again, our frequency doesn't change, is pi over 4. Now this time, since we're looking at the beginning of the positive cosine curve, right, this didn't start on the y-axis. This, we had to shift horizontally over 4 hours in order to start it. So in this case, we're going to have a horizontal shift. So I'm going to open another parenthesis, and we write t minus the horizontal shift. So again, since we had to shift 4 units over to start this cosine curve, right, the horizontal shift is going to be 4. Okay, and then close both parentheses, right, because we have an open parenthesis and an open, so let's close them both up. And then we're going to put plus our vertical shift, which we again found to be 19.5. Okay, now part C wants us to do really the same thing, but this time they want us to write it as a sine function instead of a cosine curve. Now, we know when, we switch from a sine to a cosine or whatever, the only thing that ever changes is the horizontal shift and whether we're going to put a positive or a negative in front of our curve. All right, so basically, let's start this off the same way. T of T equals. All right, so if we look at our curve here, right, I'm going to do it as a positive sine curve. We know if you look from here to here, isn't this a positive sine curve, right? It starts at the midline, goes up to a maximum, hits the midline again, down to a minimum, and ends at the midline. Okay, this right here is one complete cycle of a positive sine curve. All right, so basically, the amplitude is still 2.5, and because we're looking at a positive sine curve, I'm going to have positive 2.5 times sine of, the frequency doesn't change. The frequency, whether you look at it as a sine or a cosine, is still pi over 4. And then I'm going to put a parenthesis, and we're going to write t minus the horizontal shift. Now again, this is the beginning of the sine curve, okay? That's not on the y-axis. It was shifted horizontally 2 units over, right, to start our sine cycle. So the sine cycle starts 2 units horizontally over. So I'm going to write 2 as my horizontal shift. And then again, double close the parentheses, and we're going to have plus our vertical shift, which is 19.5. Now, there's other equations you could have used. Like if you wanted to, I don't know, let's say start here, right? Isn't this the beginning of a negative sine cycle? So you could have written, you know, another equation if you wanted a negative sine curve, and the horizontal shift would have been 6. But that's up to you. I feel pretty comfortable with what we have on the paper. Now, part D says, determine to the nearest tenth of a degree the temperature of the house at 9 a.m. Okay, so basically, I mean, if you were to look at your graph, right, at 9 a.m., which is right here, you could see the temperature looks like it's, I don't know, a little above, right? If this was 16, it's a little above 16 degrees Celsius. But we want to find what it is to the nearest tenth, okay? We don't just want to estimate. We want to be sure about our answer. So you could really use any one of these equations. It does not matter at all. I'm just going to use the first one we used. And we're looking for the temperature at 9 a.m. So we're looking for T of 9. So basically what you're going to do is pick whichever equation you want. Again, I'm picking the very first one we go. You're going to rewrite that equation exactly like you see it, but you're replacing the little t's with 9s, okay? Time t equals 9. And then really once you have this written out, all you're going to do is make sure your calculator is in radian mode and just plug this entire thing in your calculator exactly like you see it. Okay, and when you do, we get t of 9 to be to the nearest tenth. I'm getting 17.7, and that would be degrees Celsius. Okay, so I was off. I was saying 16 point something, but it's actually 17 point something. Okay? Okay, so in number 10, they're talking about the temperature in Carlsbad, California. And actually, we changed this X to a T. So T months after January 1st. Okay, now they want us to determine the period of T of T. All right, so we know the formula for period is 2 pi divided by the frequency. Now the frequency is right here in front of the T. So 2 pi divided by pi over 6. Okay, so when we're dividing by a fraction, what we're actually doing is multiplying by the reciprocal. So you could do keep, change, flip, which really just means you're going to keep the 2 pi. I'm going to put that over 1. You're going to change the division to multiplication, and we're going to flip this fraction upside down. So keep, change, flip just means you're multiplying by the reciprocal. Okay, sorry, that's so messy. I'm having trouble writing here. So this pi on top cancels with the pi on bottom. And then 2 times 6 is 12. So the period is 12 and months, because that's the time period. That's the time we're talking about, the units in this problem. Okay, now it says to interpret what it represents in the context of this problem, but I want you to be a little more specific. I mean, in terms of January 1st. So what does this mean in the context of the problem in terms of January 1st? Okay, so the period, we know period just means how long it takes to complete a cycle. So if it takes 12 months to complete a cycle, it means it's going to take 12 months for the temperature in Carlsbad, California to reach the same temperature that it was in January 1st of the previous year. Now, since this is a negative cosine curve, right, we know that it's going to be starting low. It's going to be starting at its minimum. So the minimum is equal to your vertical shift minus the amp. So since the amp is 15 and the vertical shift is 60, 60 minus 15 is 45. So basically I wrote out it takes 12 months for the temperature in Carlsbad, California to reach a minimum temperature of 45 degrees again. Okay, so now in part B, they want you to graph the function on the interval between 0 and 12. So I'm going to set up my graph in a minute, but before I do, let me just write down the important characteristics of, what we need to include. So the amplitude is equal to, now keep in mind, it's not negative 15, it's the absolute value of this number, so it's equal to positive 15. Okay, the frequency is equal to what's in front of the t, pi over 6. We just found the period to be 12, so that's how many months it'll take to complete one cycle. Let's see, the vertical shift is this number right here at the end, which is 60. So our midline is going to be at y equals 60. What else do we want? Let's do the min and the max, so we know how high and how low we have to go on the graph. So the minimum, we already talked about that too, is equal to the vertical shift minus the amp. So right here, vertical shift minus the amp. So 60 minus 15 is 45. And the maximum is equal to the vertical shift plus the amp. So 60 plus 15, which is 75. All right, so let's graph this. So we have to graph it on the interval from where x, actually this shouldn't say x either. Let's cross this off. This should be a t, right? So where t is between 0 and 12. So we're gonna have to number our t-axis from 0 to 12. Now, first of all, t represents the time, and that would be, in this case, in months since January 1st, right? So months since January 1st. And since we have to number up to 12, let's see, if you count those boxes, it looks like there's actually exactly 12 boxes. I'm not going to number every other one. So I'm going to jump 2 boxes and put a 2, 4, 6, 8, 10, 12. If you want to fit all the numbers, you totally can. That's up to you. Okay, and then this is going to be our temperature axis. So this is in terms of what? Degrees Fahrenheit, right? So this is temperature in terms of degrees Fahrenheit. And we have to, we have to reach a maximum of 75. The minimum is 45. I mean, you could put an interval break here. I'm not going to. I'm just going to, if we have to number up to 75, we have plenty of room. I'm going to 5, 10, 15, 20. So again, I'm just going to number every other one. So I'm going to jump 2 boxes and go to 10, 2 more boxes and go to 20, and so on. Okay, so I put the equation up here at the top of the page just so we can look at it. All right, so we have a negative cosine curve. Now, let's see. First thing, I want to put a dotted line where my vertical shift would be. My midline would be at y equals 60. So I'm going to put a dotted line at y equals 60. Right here. Here's my vertical shift. This is the midline of our graph. Okay, now again, it's a negative cosine curve. So we know a negative cosine curve is going to start low, come up high, and end off low. Okay, so we're going to start on the y-axis. Since there's no horizontal shift built in here, we're going to start at the y-axis at our minimum, which is at 45. So along the y-axis, I'm going to start at a minimum, which is at 45. And we know that since the period is 12, once 12 months have passed, we're going to be right here at the end of our cycle, right? This is the beginning of the cycle, and then after 12 months, we're going to be at the end of the cycle. So we're going to be at a minimum again. So at 12 months, I'm going to be also down at a minimum of 45. Okay, now halfway between any two minimums, right? So half of 12 would be 6. So at 6, halfway between two minimums, we're going to be meet in the middle and be up at a max. Okay, so we're going to meet here in the middle, and we're going to be up at our maximum, which we said was 75. So at 6, we're going to go up to 75 and put a point. Okay, and then halfway between any min and any max, we're going to be on this dotted line. So to get from the minimum to the maximum, it took 6 months. So half of 6 would be 3. So at month 3, we're going to be at that midline. And same thing over here. To go from the max, if you go 3 months forward, we're going to be down on that midline. So at 9, we're going to be on the midline. And this is what our curve should look like. Okay, and I'm going to label that T of T. Okay, so now in the next part, they want us to write an equation for this graph. Basically, look, as a sine curve, okay, and it has a horizontal shift. So, all right, let's write T of T equals. Now, we have to decide, do we want to look at it as a positive sine curve or a negative sine curve? Well, I'm going to look at it as a positive sine curve. A sine curve starts on the midline, right? And if it's positive, it goes up, hits the midline, goes down, and then returns back to the midline. So basically, this is the start of a positive sine curve. So, I mean, we could see up here, right? The amplitude is 15, so I'm going to write T of T equals positive 15 times sine of, now B stands for the frequency. Let me move that back up. So the frequency is pi over 6. And then I'm going to open up a parenthesis, and we have a little t minus. Now this stands for a horizontal shift. If this is the start of a sine cycle, right, basically follow it down, and that happens at time 3. So 3 months is January 1st. So it has a horizontal shift of 3. So that's what we're going to replace the C with. And then close both sets of parentheses, and then plus our vertical shift, which we know is 60. Okay, so this is one way that you could write it as a sine curve. Okay, so in both number 11 and 12, we are given a picture of a trig graph, and they want us to determine, well, it says determine the values of A, B, and C, but it was missing the B. So if you guys can just slide the B in here. All right, so let's take a look at it. Okay, so the A, this should really be a lowercase a, lowercase b, and lowercase c. But the A represents the amplitude, the B represents the frequency, and the C, where it's located in the equation, represents the vertical shift. Okay, so I just wrote that out. And then in addition, I wrote the formulas, right? We know the amplitude is max minus min divided by 2. The frequency is 2 pi over the period. And the vertical shift is equal to the max minus the amp. All right, so let's take a look at our graph here and let's plug in some numbers. So we know the amplitude is the max, which is 4, minus the min, which is down here at -2. So it's actually a minus negative, and we're going to divide that by 2. Okay, so we know 4 minus -2 is the same thing really as 4 plus 2. So 4 plus 2 is 6, and 6 divided by 2 is 3. So our amplitude is equal to 3. Now, this uses a capital A, capital B, and capital C. I mean, technically it should be lowercase because that's how it is in the equation. I'm just going to write them as lowercase. So A is equal to 3. Okay, this is my answer box. Now let's find B, the frequency, and then C, the vertical shift. All right, so the frequency we know is equal to 2 pi divided by the period. All right, so it's going to be equal to 2 pi divided by, well, the period is the length of one cycle. So if you look, here's the start of a cosine cycle, and if you follow it through, this is where that cycle ends. So we're starting at the cycle on the x-axis at 0 and ending the cycle on the x-axis at pi. So it takes pi units to complete this cycle. All right, so the period would be pi. And then if we simplify this, basically the pi on top cancels with the pi on bottom, leaving us with 2. Okay, so our frequency is 2. All right, and then the vertical shift is equal to the max minus the amp. So the maximum is 4 minus, we found the amp right here to be 3, and 4 minus 3 is equal to 1. Okay, and you could look at the graph and check this. So, for example, right, we found the vertical shift to be 1. Well, The vertical shift would be where your midline is, right? If this goes up to a height of 4 and down to a height of -2, you can kind of count your way in, right? If you count your way down 1, 2, 3, and up 1, 2, 3, you meet in the middle at 1, right? So we would have a midline right here, y equals 1. Okay, so that checks out. The amplitude is the height from the midline. Well, if this is where the midline is, isn't the height from the midline 1, 2, 3? Okay, so that checks out as well. And then the frequency, and I'm just thinking about the definitions. Frequency is the number of complete cycles between 0 and 2 pi. So if we were fitting one cycle between 0 and pi, we would fit another cycle once we reach 2 pi. So the frequency would be 2. All right, and then number 12 is the same type problem. Okay, they want us to find, and again, these should really be lowercase a, b, and c, but they want us to find a, b, and c. So again, a is the amp, b is the frequency, and c is the vertical shift. Okay, so if we use our formulas, max minus min divided by 2 will give us the amplitude. So the max is 5, and the min is 1. So we could do 5 minus 1 divided by 2. So 4 divided by 2, which is 2. Okay, so our A, our amplitude, is 2. All right, the frequency is equal to 2 pi divided by the period. Now remember, the period is the length of one cycle. So here is one complete cosine curve, and it takes us pi over 3 units to get there. So the period is pi over 3. All right, so now, when you're dividing by a fraction, basically you're doing either keep, change, flip, which is the same as just multiplying this by the reciprocal. Okay, so I'm going to keep the 2 pi. I'm going to change division to multiplication, and I'm going to flip this upside down. That's what it means to take the reciprocal. If it helps you to visualize this, to put the 2 pi over 1, you can. So the pi on top cancels with the pi on bottom, and then 2 times 3 is 6. So our frequency is 6. Okay, and then finally, the vertical shift is just equal to the max minus the amp. So the maximum value is 5. And then minus, we found over here the amplitude to be 2. And 5 minus 2 is 3. So our value of C is equal to 3.